All right, we're gonna just tackle this question here from one of your worksheets dealing with section 4 of the Canadian Electrical Code, and it's going over the ampacity, so the amount of amperage that a conductor can carry, using derating factors. So you need to you can find the ampacity of a certain conductor depending on its size from table 1 to 4, but then you have to derate that ampacity if the conductor is going to be going through an ambient temperature greater than 30 degrees, um, and or if it's going to be run with more than two other conductors. So more than three conductors, you got to derate as well. And both of those scenarios is because now you're going to be creating more heat on those conductors. And the more heat that there is, the less current can be safely run through those conductors. So you have to, you'll have to, if you're dealing with situations where you're going to have a lot of heat, then you have to up the conductor size for a particular amperage going through. So let's take a look at this scenario here. We're dealing with copper conductor, and we'll look at the other variables as well. So let's cancel that. So we're dealing with copper conductor. We're dealing with nine of them. They're number 12, and they're RW75, and they're installed in a raceway with an ambient temperature of 55 degrees Celsius. So the first thing we want to do is, because we're dealing with number 12, well, let's figure out what number 12 copper, RW75, so the 75 being the installation temperature rating, how much current we can normally run through those in an ideal scenario. So because again it's copper and it's run in a raceway, we're going to be looking at table 2. Table 2, from the heading, we know that we're dealing with copper and we're going inside a raceway. So that's ideal for us. If we take a look at number 12 here, number 12 at 75 degree insulation rating is good for 25 amps. Okay, so let's write that down. It's good for 25 amps. But if you take a look at the top here, it's not more than 3 insulated copper conductors. So what happens if there's more than 3? Well, what happens if there's 9 of them? Well, table 5, the series of tables in 5, deal with these situations. So table 5C is ampacity correction factors for tables 2 and 4. 2 and 4 being aluminum and or copper run in a raceway. Now, if you have a number of insulated conductors, so 1 to 3 is going to be taken at 100%, just like the table 2 indicated. But if you have more than that, you got to derate. In our case, we got 9, so that's going to be between 7 and 24. And we got to derate that at 70%. So we're going to take our 25 and multiply it by 0.7. But we also have to derate it because we are dealing with a temperature that is greater than 30 degrees. So again, if we go back up to table 2, it indicates that based on an ambient temperature of 30 degrees. So in our case, we got 55 degrees. So we got to go to table 5 again to derate, and we're going to use table 5A, correction factors applying to tables 1, 2, 3, and 4, and 6E. So we're dealing with 55 degrees. and a temperature, insulation temperature rating of 75. So we gotta derate that again to 67%. So we multiply it by 0.67. So if we take 25 times 0.7 times 0.67, we end up with a measly 11.725 amps. So under ideal circumstances, that particular conductor can carry 25 amps, but because we're exceeding the ambient temperature of 30 degrees and because we're running 9 in a conduit or a raceway, now that particular conductor can only handle 11.725 amps.